Hello friends, today we'll learn the CAN cycle for grooving G75. So for grooving purpose we have taken the grooving tool of 4 mm width and the offset is set on this corner of grooving tool. So you can see in the figure we have taken the 80 mm diameter workpiece and we have to perform a grooving operation between this 15 mm distance up to diameter of 50. So let's begin the part program for grooving cycle. So start with the program number O0004 G28 U0.0 W0.0. This is the reference code for tool. Then we are taken a tool T0303. 03 is the tool number and next 03 is the offset for the grooving tool. Start the spindle M03 clockwise rotation. Yes, 300 is the speed of spindle. G92 the spindle speed limit should be up to 2000. G96 constant surface speed. Yes, 100. M08 coolant on. Then we are moving tool to the start position of to perform the grooving operation. So with rapid motion G00 X82 and Z minus 10. So from the machine 0 position tool will move to the X82. So this is the 80 mm diameter. So tool will move 2 mm away from the workpiece and 10 mm minus in the Z direction. So up to this point tool will move rapidly from this position to this position. Then we are going to start the actual CAN cycle for grooving G75. This cycle have a two-line formula G75 R1000 G75 X50 Z minus 21 P 5000 Q 4000 F 0.15. Now we will understand the values entered in this two-line formula of grooving cycle. So let's see what we have to do. We have to write down the two-line formula of grooving and we have to enter the value with these letters R, X, Z, P, Q and R and F. So let's take first R. R is the tool return amount. R tool will cut the material and after cutting tool we have to move the tool somewhat back to the away from the workpiece. So that is the tool return amount. So then X with X letter alphabet U, the groove diameter. Groove diameter, that means up to which we have to perform a grooving, that is from 80 to 50. So final diameter of grooving is the 50. So we have to enter the value minimum diameter of grooving is 50. Then Z with Z dimension we have to enter the width of groove, that means end point of groove. That means in our figure we can see our groove will start from minus 10 and end up to minus 25. So we have to enter the end point along z axis. So you can see the groove will end up to z minus 25, but we have entered the value z minus 21. Why? Because we have the width of grooving tool is 4 mm. So while performing grooving operation, so tool will move up to this point, and we have set the grooving offset on this edge. That's why we have to give the dimension according to the width of tool. So 4 mm width, so 25 minus 4, that is the 21. So that's why we have written the z minus 21.0. Then P delta is the incremental depth of cut in x axis, and with Q incremental depth of cut in z axis. So what is the incremental depth? So when we are moving tool in x direction for cutting operation, we have to move it in step by step. So we can move the tool with a one step from start to end. So we have to move in a step by step. So first step, second step, and third step. So we have to mention the distance to move along x direction. Incremental depth, first increment, second increment, and third increment. So this is the incremental depth of tool along x axis. Similarly, we have to perform this operation along z axis also. So once we have cut the groove on 4 mm, then we have to move the tool for further 4 mm. So this is the 4 mm incremental depth along z axis. So that's why we have taken the with P and Q 5000 incremental depth, and with Q 4000 incremental depth. So these values are in a micron. That's why along an x axis, when we are moving with a 5 mm incremental depth, and along z axis we are moving with a 4 mm incremental depth along z axis. Then feed rate 0.15. Then G00, in between these two lines the tool will perform whole grooving operation, and it will return to the safe position, that is G00 x82, then away from the workpiece, and then we have to send the tool to its machine 0 position. So we are taking G28 code U0.0 W0.0, then spindle stop M05, then G97 cancellation of CSS, then M09 coolant off, and finally M01 optional stop. So in this way we can prepare a part program with a CAN cycle G75 for grooving. So if you have any doubt, you can write in a comment. I hope you understand it well. Thank you.